xShape features modeling tools with a wide variety of predefined primitive subdivision or sub-D surface shapes in both 2D and 3D. You can use these to get started on your modeling work quickly. When starting a new physical product, select a primitive that is closest to the general approximation of the final shape, knowing that you'll use multiple tools to complete the shape. Note that you can create multiple primitive surfaces and, with the additional tools and power of XForm, combine them to finalize your model. While adding a primitive sub-D surface body, you can adjust the orientation, number of loops, scale, and position in space of each as you create it. Some of these shapes, like the cylinder and cone, have a drag handle to set the rotational section in degrees. In this lesson, we'll look at adding primitive subdivision or sub-D surface shapes, using the robot to edit sub-D surfaces, and using symmetry with sub-D surfaces. Here's an empty physical product. Let's add a primitive subdivision sub-D surface to start our design. To get started, I'll move to the subdivision action bar. You'll see a variety of primitive shape icons, and then I'll click the cylinder. The selected primitive appears on the cursor and orients normal to the plane that you hover over. It can also be reversed by pressing the Tab key or placed at the origin position by pressing the Enter key. There are several ways to place a primitive: at the origin position, on a reference plane, on a reference point, on an axis, or normal to the face of an existing sub-D surface. In this example, we'll click to place the cylinder on a plane. It is placed by the bottom center. Looking at the dialog box, you'll see a slider to control the scale of the entire body before it's placed. I'll drag the slider a little beyond the 150 mark to increase the size. Note that the scale number does not correspond directly to specific units, but it is useful relative to other geometry. The mid-plane option places the primitive's center of gravity at the placement location. Flip direction performs the same function as the Tab key after placement. Dragging the handles scales the body locally in one of the three directions. The handle on the outer edge is used to drag a section of less than the default 360 degrees. It is only available for cylinder, globe, torus, and cone primitives. The number of loops in each of the three directions can be set using the labels. When you click OK, the primitive is added and remains selected. Why does it remain selected? At this time, the entire primitive can be moved, rotated, or scaled using the handles in any of the three directions. If you are satisfied with the position, orientation, and size, simply click Air off of the geometry to deselect it. Although nothing is selected, the primitive remains active and can be edited until the OK button is pressed. Note that only one primitive sub-D surface can be active for editing at a time. This is called the freeform environment, and it contains many tools that are specific to primitive sub-D surfaces. Let's take a quick look at them. Knit to Solid is on by default, and it knits your primitive sub-D surface body into a solid body when OK is clicked. Transparency uses a slider for you to set the transparency percentage of your primitive. The Mesh Cage toggle allows you to show or hide the controlling mesh cage of the primitive. You can edit with the cage on or off. Select Only Visible is off by default, and it prevents you from selecting geometry that is hidden from view. The selection filter contains multiple options for you to filter by any entities, the default, vertices, edges, faces, edge rings, edge loops, or face loops. Let's talk about the most common and one of the most useful forms of editing, pushing and pulling or dragging the shape. In order to do this, you'll need to know a little about selections and the robot. This time we'll use a different yet common primitive sub-D surface type, a box, to create a remote control type of model. It will be added using all of the defaults. I just click the box primitive icon and press the Enter key. It appears at the origin location. The most basic selections use the left mouse button to select geometry. In this case, a face. As I mentioned, the default selection type is any entities, so there's no need to change the filter. After the first selection, the robot appears. The robot is an incredibly simple yet powerful tool that manipulates the geometry by pushing, pulling, rotating, or scaling the selected geometry. We'll discuss it in detail in a minute. I'll press the Control key and select more faces, 3 in total. The robot will center itself based on the combined set of selections. What is the robot? It is a set of coordinate axes that includes several handles that can be pushed and pulled to manipulate the selected geometry. Axes, marked as arrowheads, that can be used to push, pull, or drag in axial directions. Planes, marked as shaded areas inside the arcs, that can be used to push and pull in planar directions. Arcs, that are used to rotate around the axes. Scales, marked as balls at the end of the axis, that are used to scale larger or smaller in one or two directions. And a larger center ball that is used to control the orientation and position of the robot. Move the cursor to the normal facing axis and push it into the body about 20 millimeters. Click Air to clear the selections. I'll change the view orientation using the reference triad. You can see that the faces have been pushed but remain connected smoothly to the adjacent faces of the model. How about selecting a large amount of elements? The best way to do this is to use box selection. Change the view orientation to an orthographic view like front, top, or right. Use box select to select a group of vertices. Note that even when you select faces, you're really selecting the vertices of those faces. This is also where the Select Only Visible Elements option comes into play. It is off by default, so all the elements through the model are selected by the box. After selection, the robot appears and the length of the body is pulled, increased by about 200 millimeters. Note that moving close to the ruler provides more even intervals, in this case 5 millimeters. Clicking Air again clears the selections. Now let's take a look at some other selection techniques and scaling. This time let's use a filter, face loops. Face loops are the rows of faces that run around the model in both directions. I'll select the face loops filter and select a face loop. 2 loops are possible with each face, depending on where you pick. This time I'll use the scale option, the small ball at the end of the axis, to pull, push, and scale in a single direction. That isn't what I wanted, so I'll click Undo or press Ctrl Z to undo that change. I'd like to scale the same amount in 2 directions at the same time. This is useful for a box and also for shapes like cylinders and cones. I'll select the face loop again, but this time I'll click one of the scale handles to highlight it. Then I'll move to the other handle in the plane that I want and push it inward, shaping the geometry and keeping it square. Note that the highlighted handle may stay selected, so you may have to click it again to turn it off if you don't want to use it. Many designs are symmetric, and we can take advantage of this by using xShape's symmetry tool. Here I'll create a motor oil bottle that has symmetry about one plane. Symmetry is a real time saver as it lets you design one side of the model with the changes transferred to the other side across the symmetry plane. The plane is often one of the standard three, XY, YZ, or ZX planes, but it can also be one that you have created. While the tool is active, a green edge representing the intersection of the plane and the sub-D surface appears. If you plan on using the symmetry tool, it is best to place the sub-D primitive on the plane of symmetry. If you want symmetry to be available for use with all three standard planes, it is best to place the sub-D primitive at the origin position. The easiest way to do this is to add a reference point at the 0, 0, 0 position. To do this, click the Features action bar in the Plane pull-down and click Point. Using the default offsets of 0 mm for X, Y, and Z, click OK to add the point. Click the Subdivision action bar, the sub-D primitive box, and hover over the reference point. Click to place it there. The freeform dialog appears, and I'll dial the scale up to about 200 mm. Note that I'm using rough estimates here because more specific values can be applied later in the process. Let's set the number of segments in the Z direction to 5, using the label, and click OK, and finally click Air. Let's start with the changes right away, those changes that do not require the symmetry tool. Change to the front view, box select the upper vertices, and pull upwards about 100 mm, and again click Air. This bottle has an angled top, so I'll select the top left couple of rows of vertices, not the whole top. Using the Arc tool, rotate the vertices about 20 degrees counterclockwise. Once you've pushed, pulled, rotated like this, just wait for a second to see the results. Don't be too quick to move the mouse again, or the shape may continue to change. I'll mention to click Air this one last time. It's the quickest way to clear the selections you've made. I'll press the space bar and change to a side view. Alternatively, I could have pressed the Shift plus the arrow key twice. This is the view we'll need to use with symmetry. One other change I'd like to make before I start symmetry concerns the loops. You may need to concentrate loops in the areas you're changing, and I'll select the loop and move it about halfway up. Now it's time to start the symmetry tool. Click Symmetry. I'll select the YZ plane from the screen, but note that I could have just as easily selected from the Design Manager. Click OK, and symmetry is on. I'll select some vertices on the right side and push them inward along the normal axis to squeeze the upper portion of the bottle. Now I'll select the vertices along the right side, but not along the symmetry plane. Note that, like the previous change, the normal axis is not quite horizontal, but I'd like it to be for this operation, changing the width of the bottle. I'll right-click on the center ball of the robot and click Set as XYZ. This reorients the axes of the robot to align with the XYZ of the planes. Now when I push inwards, I am pushing along the original axes of the sub-D primitive. We're done with symmetry, so I'll turn it off by simply clicking the icon again. We're also done with this sub-D primitive surface, so I'll click OK. Note that the Design Manager includes both the subdivision surface and a knit surface feature. The surface has been converted into a solid. This bottle will need a spout, and although your first reaction may be to add in a sub-D cylinder, if you want a true cylinder, it is best to create prismatic shapes with the tools in xDesign. The same is true for lines and arcs. I won't get into the details of switching to xDesign, adding a cylinder, fillets, and a shell in this lesson, but the results would look something like this, a combination of fully editable sub-D and prismatic geometry.